This is the last video tutorial for Lab 6, and in this tutorial I'm going to specifically show you how to measure the angular diameter of spiral nebulae, but just more generally remind you how to measure the extent of a distributed object in your image. So let me share my screen. Okay, so here is one of those spiral nebulae, which we nowadays call a galaxy, that I observed. And this is Messier object 65. And we want to measure its angular diameter, so how big it is from here to here. You know, the whole thing is probably symmetric, but we're looking at this particular one almost edge on. So we're not going to measure going across this way. We're going to measure from this tip down to this tip. Now to do that, we need to see the outskirts of the galaxy as good as we possibly can. And so what we're going to want to do first is change the brightness and contrast. When you load it in, it's set to the default setting. I could switch over to the faint setting and see more of the outskirts, or I can even make it even a little bit more extreme. So instead of a saturation level of 99 or 95, I recommend that you change it to 90. Okay. And so now we can really see the outskirts. The galaxy seems to end around here, and on the other side it ends right around the edge of the image. So next we're going to go over to the plotter tool. It has a little ruler icon. And we want to make sure that centroid clicks is off. We're not trying to measure the distance from one point of light to another. We're trying to measure across a fuzzy object, so we do not want any centroiding. And then you just have to kind of eyeball where you think the edge is on one side and where you think it is on the other side. And then you can measure that in arc minutes down here. And arc minutes is the best unit to use. Now, when you take your picture, they're not always going to come back perfectly centered. And these are fairly nearby galaxies. And so if there's a little bit of a pointing offset, the whole galaxy may not be on your image, and that makes it difficult to measure the angular diameter. But don't worry, you can still make use of the image. Just measure the angular radius and multiply by 2. So, and this is almost an example of that. The edge, this lower edge of the galaxy is right near the edge of the image. So if I didn't trust that, let's see, what did I get? 8.33 arc minutes. Let's try to measure the angular radius. So you pick a point in the center and go out to the outskirts. And I got 4.28, and so I would then double that. It'd be 8.56, 8.57. So a little bit longer than what I got here. So maybe it does go off the edge of the image just a little bit in this particular case. Anyway, you get the idea. So go ahead and make those measurements for all of your what used to be called spiral nebulae, and then you'll use these angles, combine it with the known distance to these galaxies, which you're computed using Cepheids, to figure out how big these galaxies actually are. And that will tell us whether our Milky Way galaxy is unique. Is it the primary largest object in the universe, or is it typical of galaxies out there? Okay, that's it.